And now you just have to find the forward difference of tangents of x. So I'm going to start by saying that tangent of x is the same thing as saying sine of x over cosine of x. So by finding this forward difference of tangent of x, we are simply saying what's the forward difference of sine x over the cosine of x. Well, this can be written as sine of x plus h divided by cosine of x plus h, and we subtract the original function from it, sine of x divided by cosine of x. So by saying forward difference, we go forward and we subtract the original function from it, right? So this h is just a little interval. Okay. Now from here, I'm just going to get a common denominator by finding the LCM, and I'm going to multiply through by the LCM. So I'm going to get, after everything, I'm going to get sine of x plus h, then cosine of x, and also minus sine of x, then cosine of x plus h, and in the denominator, just multiply the two denominators. I'm going to have cosine of x and cosine of x plus h, like this, right? Now, in the numerator, I'm going to do a lot of expansion right there. Okay, so this is going to give us, well, here from identity, I'm going to expand this. I'll have sine of x cosine of h plus sine of h cosine of x, alright? And I will still multiply that with cosine x. And again, on this side, I'll have sine x times, well, still the same thing, but this is for cosine. I will have cosine of x cosine of h. This is addition, so I'm going to subtract sine of x and sine of h, like this, right? And in the denominator, we still have what we had. So that will be cosine of x and cosine of x plus h. I don't want to expand this because I've seen already there's no point, right? We're not going to make use of that. Well, just multiplying through in the bracket, we will just enter with cosine of x times the first, so we have sine of x, cosine of x, then cosine of h, like this. And here we just have sine of h, then cosine of square of x. And again on this side, we're going to enter with sine of x, then cosine of x, and this is cosine of h, not hyperbolic cosine, right? This minus and this minus, we're going to have a positive sign. So that is just sine of square x. Yeah, this is cosine square. So this is sine of square x and sine of h. In the numerator, so we can just get a common denominator still with us as it was. This is x and this is just x plus h. Now, in the numerator, I want you to see that this and this, they are equal in magnitude, sine, sine, cosine, cosine, and cosine h, cosine h. So since they are equal in magnitude and they are opposite in sign, so they will get to 0. And on this other end, we have sine h is here and sine h is here, so we can factor that, right? So by factoring that, we're going to have sine h in the numerator. Now this will be cosine of square x, and this is just plus sine of square x. Now the denominator still remains cosine of x and cosine of x plus h. Very nice. Now in the numerator, you can recognize this, right? Well, this is just here. It's just what I'm writing here, so it's nothing different. It's just what I'm writing here, so it's nothing different, right? So in here, we can just have this to be, let me turn this okay. So here, we can just have this to be the same thing as, now where cosine square x and sine square x gets to 1, we just multiply that with sine h, and we just enter with sine h, just an identity element. And in the denominator, we just have the same thing, cosine of x and cosine of x plus h. Well, this is the place we can stop for the forward difference of tangent of x. So this is just a direct expansion, but it's actually the same thing. Okay, thanks for watching and thanks for subscribing as well.